Welcome students, we have been given this question 3 over 1 factorial positive, 2 factorial positive, 3 factorial etc. It goes up to 2024 divided by 2024 factorial, positive 2023 factorial, positive 2022 factorial. This is a beautiful question and it involves a series which has factorials embedded. And we are expected to solve this question. And how are we going to solve it? So this is the strategy that we can adopt. Now clearly you can see that you have a 3 here and you got a 3 factorial, and immediately the factorial gets deduced by 1 and then subsequently it again deduces by 1. So is it okay that if I can rewrite this as say m positive 2 divided by, I start here m positive 2 factorial, positive m positive 1 factorial, positive m factorial, right? So m takes the value, in this case m takes the value 1. When m is equal to 1, I get the first term 3 divided by 3 factorial, 2 factorial and 1 factorial. M is equal to 2. I get the second term. So m is equal to 1, 2, 3, etc. It goes up to until it reaches this particular quantity which we have got here. But of course it's not going to be having this quantity 2024, because when for m is equal to 1 we are getting 3. So naturally you will have to subsequently make that adjustment. Now I'm just giving you this pattern. Now using this, it is more than enough for us to solve this question. So how are we going to solve this? Now I'm going to rewrite this entire quantity as m positive 2 divided by m factorial. I want to split this m positive 1 factorial as m positive 1 times m factorial, followed by, I'm going to split m positive 2 factorial. So that's going to be m positive 2 times m positive 1 times m factorial. So clearly I've got a m factorial being present on each of these terms. Now what I wish to do is I would like to take m factorial out. If I were to do this, I would get a 1 here, followed by m positive 1 for this term, followed by m positive 2 and m positive 1. So this is equal to m positive 2 divided by, now I'm taking m factorial out, now m positive 1 positive 2, so that's going to give me m positive 2 positive. So this is going to be m positive 2 times m positive 1. Now this is equal to m positive 2 divided by m factorial. Now m positive 2, m positive 2, and I can take that m positive 2 out. So if I were to do that, I will get a 1 here, followed by m positive 1. Now this is equal to m positive 2 divided by m factorial, m positive 2 times m positive 1 positive 2. So that's going to give me m positive 2. So I can clearly cancel m positive 2 and m positive 2, and that would mean I now have 1 over m factorial times m positive 2. Now you can clearly see that the 3 components which we have found in the denominator has been reduced to 2. Now I would like to go still further and reduce it to 1. So for that, what I'm going to do, I'm going to be multiplying the numerator by m positive 1, and I'm going to divide it the same by m, in fact multiplying and dividing by m positive 1. That's what I'm doing. So this can be rewritten as m positive 1 divided by, you can clearly see we have m positive 2, m positive 1 and m factorial. So I can write this as m positive 2 times factorial. Now I can rewrite the, so now you have just one term in the denominator. So we started with 3 and then we came up to 2 and now we have just 1. Now what I wish to do is I would like to rewrite the numerator as m positive 2 negative 1, that's same as m positive 1, divided by m positive 2 factorial. Now this quantity I can rewrite it as m positive 2 negative 1 divided by m positive 2 factorial. Now using algebra I can rewrite this as m positive 2 divided by m positive 2 factorial negative 1 over m positive 2 factorial. Now this is equal to m positive 2 divided by m positive 2 factorial. I can rewrite it as m positive 2 times n positive 1 factorial negative 1 over m positive 2 factorial. Now clearly you can see the m positive 2 can be cancelled. I'm going to use this space here. So I'm going to get 1 over m positive 1 factorial negative 1 over m positive 2 factorial. Okay, this is what I've got. So the entire term that we have taken, this is exactly nothing but the first term, right? The first term is represented in this fashion, and this in turn is now represented like this. So clearly what we can see here is that the first component 3 factorial divided by 1 factorial positive 2 factorial positive 3 factorial can be now rewritten as this has been produced by this, for which m is equal to 1. So what I would do is, in this case, if I were to take m is equal to 1, the first component can be rewritten as 1 over 2 factorial negative 1 over 3 factorial, right? So this is what we have got. So this is for the first term. Now moving on, is it okay? The second term, can I write the second term? The second term was generated when m is equal to 2. So if m is equal to 2, this is going to be 3 factorial minus 1 over 4 factorial, right? So this is going to be 1 over 3 factorial negative 1 over 4 factorial, and so on and so forth, plus it goes on up to etc. And coming over here, 2024, what is 2024 is going to be? It is going to be 1 over 2023 factorial minus 1 over 2024 factorial, right? Now clearly you can see 1 over 3 factorial with a negative sign will be cancelled with 1 over 3 factorial. So this is going to be cancelled. Now this is a series. So similarly, negative 1 over 4 factorial will be cancelled with positive 1 over 4 factorial. And we can stretch it all the way up unto the last term. So if you were to look into the terms that are basically remaining, that's going to be the first term and the last term. So 1 over 2 factorial negative 1 over 2024 factorial. This is what is remaining. And what is this? This is going to be my solution. And that is what is required. The question wants us to evaluate. So what we have evaluated this entire series. And the solution for that is 1 over 2 factorial negative 1 over 2024 factorial. So this is a beautiful question. Students, thank you so much.